Many people in my YouTube comment section ask me how they can make their application scalable. There is a difference between fast and scalable and slow and scalable. Fast and scalable simply means you can throw as much requests as you want at a server and it will be able to handle the load and it will be able to perform all the operations then and there. That is fast and scalable. An example of slow and scalable would be that let's say that you are uploading a CSV file of 10,000 customers information, and for every email column you need to send out an email and you had to create an account on Stripe account. A slow and scalable system would be just reading the file, storing it in database, and later a cron job picks 20 of them at once in batches and then creates the account in Stripe as well. So performing in chunks and getting the operation done that way. In that case, we will also call it scalable, but that will be slow and scalable. Basically pulling tricks on people to let them know that their request and their whatever they want to do has been accepted. It's just that the background process of the server will keep it running. So these are the two types of scalability that you have to keep in mind. Do you really want to dedicate all of the resources to that one request, get it done right then and there, and then return the response back to the user telling them that it has been completed? Or maybe send it to a different thread, a different job queue, a different service that will perform the operation eventually on it based on a clock or based on a round robin schedule. So you have to make that decision in your head, that what do you want out of your web application to do. Now normally, given that I have been building Laravel applications, my go-to approach is slow and scalable, because Laravel offers job queues and everything. So I would rather create job files of operations, insert them into the queue one after the other, and let the scheduler pick it up and process them. So that is slow and scalable. Now let's talk about some of the approaches that you can use if you want to achieve scalability. One of them is database query optimizations. One thing that you need to understand when you are building a web app is that your scalability doesn't happen at the front end, or maybe front end developers can correct me on this. But if you really are looking for scalability, the first thing that you should be looking at is your database queries. When you are creating modules, you really have to question how many queries you are performing on the database. Sometimes we end up repeating the same queries over and over, in which case the architecture comes into question, how you have put your code into modular part that makes the least amount of database queries and just blazes right through the code. Let's say in some case what I've seen happen is somebody will create a function to get something from the database. I'm taking a very simple example to begin with, and they will be passing an ID in it, and in that account what will happen is return table.find1 where ID is ID. Now this, if you take a look at this one function, get account, this is scalable, this is good enough, because if the operation is happening on a primary key or an indexed column, it will be very fast query. But let's say that further down your code, the further you built on top of it, the more and more code you wrote around this one function, and it just so happened that some function has a for loop, and that for loop function is calling this function over and over again, in which case that is not a scalable solution, in which case that is not a good solution to begin with. But in the long run, it wouldn't be scalable, because in that case, what you should have done is you should have written another function which would be accepting an ID of arrays, and you should have performed the in operation on the table, in which case that would have been scalable. Another way to achieve database scalability is limit and offset. You must have heard about these two identifiers, limit 100 and offset 200, in which case you are only taking out a chunk of the database data. Another thing is indexes, and by that I mean either primary key or unique key or just a normal index on the column that will get queried a lot, in which case these things they help with database query optimizations. Other ways to optimize are, I have seen many people that do not prefer to use joins, in which case you should use joins, that those are faster queries, because what they will do is they'll perform one query on one table, another query on another table, and then they will map it together. They will merge it together inside the code, in which case if they have performed just a join, that would have been faster. But now let's level up a little bit. Now we are moving into caching, and the reason that we move into caching is because one of the approaches that you can use when you are building a scalable application is not disturb your database as much. Not everything has to be taken and stored and read from the database all the time. Sometimes you can introduce a middle layer caching, which will be your cache layer, that will be very very fast in terms of read and write speeds. We normally use Redis, but you can also use DiceDB. Yeah, DiceDB. These are tools specialized with read and write high speeds, so you can, store some data in your Redis before you move it on the database, or you can read some information from the database, store it in Redis, and then pass it off to the user so they can work with it. In which case, you achieve a little bit more scalability when it comes to caching. And the one thing about caching is that nobody knows when to invalidate the cache and when to refresh the cache and everything. In which case, this is very, nuance-based approach to scalability. You really have to understand what is the validity of the data that you are caching. How soon does it go invalid? In which case, this is one of the methods you can use. I mean, how you write code does matter, but I would say it only has like a 5 to 10% role in, scalability. If you optimize your database query, your web apps could be, on the next level. Oh, microservices. I forgot entirely like microservices. So hardware level scalability level 1 is microservices. The thing that you are looking at is Docker or Kubernetes, obviously. I haven't worked much with Kubernetes, but I assume that it is along the same lines of Docker. Is one way to scale up your app in a little bit, in which case you would be able to take a module that your app is performing. Let's say that your app is taking a bunch of text and it is tokenizing it. In which case, you can take the tokenizing function, put it inside an Express.js app, expose the 3000 port or 4000 port, whatever, and put it inside a Docker container. Now, at least you can distribute the computation power a little bit. You have two CPUs, your main server and your Docker container, and they will be having their own resources. And if you put multiple Docker containers and each having its own capabilities, let's say a set of APIs even work. Let's say one is just dedicated to talk to Stripe API and it is just supposed to give you the information back. That would be very weird if you did that, but I'm just taking an example. So that is one way to achieve scalability as well. Your main server is always free and your main server only talks to Docker containers which are good at doing one thing. In which case, that is also a good way to scale your app. The reason that we use these things, Docker specifically, is because technically you can build a monolith and all of it can run on one server, but it can jack up your CPU utilization, it can jack up your memory utilization. And it just so happens that if you're on a plan that is like pay as you go model, let's say how much CPU you use is how much you pay, or how much memory or how much network bandwidth you use, it can jack up the prices. So if you break it down into Docker containers, it is sort of easy to keep track on how much operation and load each of them is having. So now let's get into what I did when I was working for a client that had a really scalable app. It was AWS load balancer sitting at the very top in our AWS account. That load balancer was configured to hit the target groups based on like port 443, then it would go to a certain target group. That target group had 3 EC2 instances, and the job of load balancer is to take a look at which EC2 instance it's gonna forward the request on. And these 3 EC2 instances were connected to 6 Docker containers. There was one Redis layer, then there was one Elasticsearch layer, then there was one AWS RDS database. So yeah, the bill for this one was about $6,000 a month, but they were making enough money to, easily cover that expense. This is basically how you scale up your applications. I mean, this is just one example. If you really want to mix and match different tools and come up with your own, pricing, then that would be one thing. But to handle the kind of load that I built the application for, this was what I did. There are other things that people say is that horizontal scaling and vertical scaling, and that is something that is such bullshit to me. Like, vertical scaling should not be your approach, because vertical scaling, I think, introduces the room for you to think that you are not at fault with optimization of your algorithms and everything, and all you need is to add more RAM to the system, in which case it can go forever. But horizontal scaling, at least you are creating its own resources for each of the instance. I don't think that you should just keep adding CPUs to the system. It's just no, because it's at the end of the day, it is just one machine, and if that one machine crashes, your entire web app is gone. So I would much rather have horizontal scaling. So at least one of the nodes go down, it's only that node that goes down. It actually helps for testing. So if you, let's say that if you have some kind of hotfix that you are pushing to a branch and you only want that branch to be deployed, go into one of the instances, switch to that branch, pull it, and then only deploy that node and see if it holds up. If it holds up, then you know that your fix is correct. Vertical scaling takes that away from you. ultimately it's all the one branch that is deployed on the system. So these are some of the things that I wanted to discuss about scaling. Best of luck if you're creating something. I know that it is difficult for college students to create some local development project. There are very less ways that you can really test as a college student if your app will hold up. The real test is the real world, where you get threatened by hackers, you get threatened by idiot users of your app that don't understand the UI UX that you have laid out, your client's requirements and all that, and the essence of the application, the problem that it is solving. Scalability kind of covers every little aspect of the application that you're building. So you have to understand from the start to the end to end deployment, you need to understand. So yeah, best of luck, and I think this answers your question about scalability, and I'll see you in the next one. Thank you.